Yeah. I'm going to see them. Okay, I have some of these worked out, so I wouldn't have to look at all the numbers. Anyways, we were on number 3. A survey from Teenage Research Unlimited found that 30% of teenage consumers receive their spending money from part-time jobs. If 5 teenagers were selected at random, find the probability that at least 3 of them have part-time jobs. Note, it states at least 3. The formula here. So to use the formula, we need to know what N is, X, P, and Q. A survey from teenage research on London found that 30% of teenage consumers receive their spending money from part-time jobs. If 5 teenagers are selected at random, N is how many times you're doing it, so we're selecting 5. X is how many successes we want. You want at least 3. P is the probability of a success, and it said they found 30% of teenager consumers receive spending from part-time jobs. So P is 30%. It's a decimal. If P is 30%, what's Q? No, the formula gives exact, like if we put in 3, it's exactly 3. We want at least 3, which means 3 or more. So we have to find this for X equals 3, 4, and 5, because there's up to 5. Can't have more than 5 because you're only asking 5 people. So at least 3 means we have to find 3, 4, and 5. So you have to find the probability of 3, the probability of 4, the probability of 5, and add them together. I'll move the formula down in case you don't have it. Now, depending if you're using the combination from your calculator or this formula, that means the same thing. On Alex, if you click on the little calculator, it has the combination formula there. The first one, it's 5 choosing 3. And then your probability of success to how many you want, and then failures, n minus, oops, n is 5. You're getting 0.132, 3 decimal places. For 4. Plug it in your calculator, make sure you're getting it. For this one, you should get this. Then you just change your 3 to a 4. And then you change your 4 to a 5.
Is it always 5?
This is,
Or is it, it's always your end?
it's your N, whatever your N is. And these two should add up to N, which in this case is 5. So this one would be 5 choosing 4 successes, 0.34, 0.7 to the first. These two add up to this. On the exam, there'll probably be one where you gotta use the formula. And then probably an exact value, and then there's a table I'm gonna show you. Also. I think on Alex, it just has anyone done this one yet? I thought I only saw it with the formula. I didn't see them showing you the table. Then on normal distributions, it lets you cheat and then actually the calculator finds the z value.
This is the index.
Yeah, you will. It'll probably be one where just that's the exact value, so I know you know how to find it, and then the table would be one where you find it. Any questions on that? So then we would add those up. And you'll get 0.162. Show you the table. Now the table, this one's a binomial distribution. Here's your n, and then these are your x's, and then you go to your successes across the top. So ours was 5. Now, if we look at the first one, probability of 3 successes, we go across to our p-value, which was 3.3. So here, 0.132. Pretty nice. And then the next one, 4 is right under it. And the next one's right under it. And then you just add those together to get your answer because we wanted more than 3. So you go to your n, and then it'll have all the special cases because you can only have from 0 to 5 successes. So they're all there, and p is across the top. Of course, if you had a p that wasn't up there, then you couldn't use the table. The 3, our probability was 0.3, it's right here. And then 4, and then 5. Any questions on that? Number 4. A public opinion reported that 5% of Americans are afraid of being alone in a house at night. If a random sample of 20 Americans is selected, find these probabilities by using the table. So I'm going to put these side by side. What is our n in this problem? Anyone? I couldn't hear. 20? 20. So we need to go all the way to 20. What's our p-value? The p-value is 0.05. And I believe that's the first one. Yeah, 0.05 is that first column. So it would be in this first column. No, these ones here that are empty, it's just very unlikely for it to happen. It would definitely be an outlier. So that probability is 0, that's why they don't show. There are exactly 3 people in the sample who are afraid. If we were using the formula, we're doing 20 times, we're choosing and getting 3.05 to the third, 0.95 to the 20 minus 3, 17. So if you're using the formula, this is what it would be. .05 was the first one. 3 successes, 0.06. Any questions on that?
Where did you get the 3?
Exactly 3.
Oh, wait, what? Oh my God.
So the 5%, 0.05 was from here. That told us it's the first column. The 20 was from here. And we want exactly 3. Go ahead and try the other 4. I mean, the other 3. Make something more. You want to watch for these keywords. Like the first one said exactly 3. At most 3. At least 3. You have to watch for those little words. They change the whole problem. At most 3. Am I including the 3? And am I going above it or below it? Above. If I have at most $3, do I have?
No.
No. It always helps when you think of money. So this means X is less than or equal to 3. At most 3 means I have $3 or less at most. So that would be none, 1, 2, and 3.
Then what would it at least be? What would that be?
That would be this one. What do you think? What is it?
1, 2, and 3, right?
At least, if I have at least $3,
Just that.
I have at least 3. I have 3 or more. I know there's 3 ones in my purse. There could be more, so I have at least 3. Yeah, you wanna, be careful of the wording. So this one would be X greater than 3, and it would include the 3. If it said I have more than 3, then it wouldn't include the 3. So they're gonna give you the same one like 2 times or 3 times, and then when you have to do your last one, they're gonna change the wording and it's gonna start you all over. So be careful.
So wait, that's the answer?
Well, no, you gotta find all of
Oh,
them.
I was about to say.
Yeah. So it would be 20, and we want 0 through 3. So we would add from here up.
Okay, are we gonna use those on the test?
A table? Probably, yes. I would give the table. Or I'll put it up here. Yeah. I think it's a nice, simple way that I could make sure you know the wording, but you can still find the answers quickly. Okay, so 0.05 was this column. N was 20 because it's a sample of 20. And then we wanted 0, 1, 2, and 3. So we look at 0, 1, 2, and 3, we add these together. So it's 0.358. Zero 0.984. So at least 3. Now, a lot of them are zeros, which is nice. Remember, if we're doing at least 3, that's including everything except the ones that are less than or equal to 2. So when you have a lot of them, if you had to plug in a formula for every single one of these, that would be a lot. So you could take 1 minus the ones that aren't included, 0, 1, and 2. Because this is 3 and up, you could subtract the lower ones. Now, of course, using a table, and most of them are zeros, it's not too big of a deal to add 3, 4, and 5. But if there were numbers for all of these, like over here, that would be a lot of them to subtract. So you could do 1 minus and take the probability of the 0, the 1, and the 2. So just like before, when we had a lot of things.
Wait, so what's the difference between the last ones we did that was like at least 3?
Okay.
Why are we going letting up the 20?
At least 3 means 3 or more, and we're asking 20 people. Luckily, a lot of them are zeros, so it wasn't too big of a deal. But if we had to add all of these, it's easier to just subtract the 3 that are included because they add up to 1. So we could add all of these up, or we could take 1 minus the values that are not included, which are 0, 1, and 2. Notice if we just add those up, they would be these 3, because everything else is zeros. And if you add these up, you get the same value. With the table, doing it the first way and adding them all up is not that difficult, but if you had to use the formula and do it 17 times, it's better to subtract the others. This table, if you go under chapter 5, there's a link right to it. So go in the book, chapter 5. When you're doing these problems, if you want to use the table, that's where it's at. Any questions on the at most or at least?
What did you divide by to get the decimal points for that, these 3?
For this,
Like the 1 minus, yeah, what did you get those?
from the table.
Oh, okay.
So we're gonna.
Yeah, I just use the table for these again.
We're getting the table for our tests.
Yes, there'll be one problem where you'll use the table. So there'll be one problem where there'll be an exact value where you will plug in, like we did the first problem.
Like this or like the actual equation?
Like number 1, 2, and well, 3, if it said exactly 3. So there'll be one where you have to plug into a formula one time. You won't have to do like 4 of them. And then there'll be a question like this one, where you just use the table. Oh, here, we did here. So there's one problem like this where you have to use the formula. And then there'll be like an at most, at least, where you use your table.
Can we use our calculator?
To add them, you mean?
You can do that combination thing.
To use the combination. And I'll bring my calculators, which also have the combination and the permutation on it. Like this problem here, you could use that formula. You just use it 4 times and then add it together. Any questions? We'll do another one. I think I have another one. Oh, we didn't do this one. There are between 1 and 3 inclusive people in the sample who are afraid of being alone. If we wanted 1 to 3. Inclusive means you're including them. If it just said 1 to 3, not including them, then it would only have been 2. So you want to take the probability of 1 plus the probability of 2. Using the table, you just add up the 1, 2, and 3.
Columns.
Well, we were using the same problem, so it's still the first column. Yeah. This was D, I think. Yeah. So this was using the same problem, the 0.05 with the 20 people. Any questions on using the table? Okay, with the table, or you want to do another one with the table? Cool. With a distribution, we can find a mean, a variance, and a standard deviation. For binomial, it's not too bad though. The mean is just your n times your p. Standard deviation, n times p times q. Or, sorry, variance. Standard deviation, I don't usually use variance. Standard deviation, we take the square root of that. So this is only for binomial distribution. The mean is n times p, variance, just multiply that times q. Standard deviation, just take the square root. Toss a coin 4 times. Tossing a coin 4 times, how many outcomes are there? We're doing it 4 times. Each possibility has 2, a heads or a tail. Binomial, it has to be 2s. You could write all of them. You could use a tree to find all of them. But you need a probability distribution in order to find the mean and standard deviation. Well. So we know there's 16 possibilities. If we toss a coin 4 times, n is the number of times you're tossing it. What's the probability when we toss 1 coin that we get a head? Okay. The mean is n times p. I was thinking I was gonna write probability distribution, but you don't have to for these ones. So if we toss a coin 4 times, we will probably get 2 heads. If everyone in the class tossed coin 4 times, on average, if I averaged it all together, we'd have an average of 2 heads. For the variance, we need Q. What's Q? Which is also a half. Good one. I think it was last class. We actually made the probability distribution for this. For the number of heads, it was 1 through 4, 1, 2, no, 0, 0, 1, 2, 3, and 4. We found the probabilities and multiplied them, and we found the mean variance and standard deviations the other way. This is shorter. Any questions on this one? Okay, go ahead and try the second. Funny. The exam is 2 weeks from Friday. One more capture. So the next exam is 2 weeks from Friday. This is definitely a mean standard deviation one I would put on the test because it's the simplest standard deviation. I mean, on the in-class part. So what is N?
Wait, I did attention. 560.
560? We're rolling an 8-sided die with the numbers 1 through 8. What is the probability that you roll the number 7? So then Q is 1 minus 1/8, or 7/8. What did you get for the mean? 70. 560 times 1,770. What did we get for the variance? Oh. You can, this is a case where you would use a decimal. Five, 1/7, oh, sorry, that should be 1/8.
Okay.
Sorry, thank you. My mind goes faster than I write.
Like, where did we get that?
7-sided dot. That's not a bad idea. I should pull out, I think it goes up to a 20-sided one. You guys can play with them on Fridays. So for this one, you just take that answer and multiply by 7/8. Because N and P is the 70 times 7/8. Yeah, 61 1/4. No rounding, you should go one decimal place further than your data, so 61.3. Sometimes Alex follows that, sometimes it doesn't, so just see what he tells you to round it to. And then this one, you just take the square. Whoops, wait a minute, I started looking at the wrong one. Any questions on that? Okay, go ahead and do the third one. Getting 650 for the mean. So N was 1,000. Success, 65%. Written as a decimal. So 1,000 times 6,500 is 650. Was doing problems on Alex and he doesn't like, or she doesn't like when I don't put the 0 in front. It says it's correct, but you should have a 0. But at least it didn't mark it wrong. 227.5. and then the square root of that. Any questions on that? So the hardest thing is finding the probability. Sometimes it's just given, and other times, like the rolling 8 dice, you have to figure it out. 2 out of 3 dentists, probability 2/3. Expected winnings of a game. Felipe is playing a game of chance in which he rolls a number cube with sides and numbered from 1 to 6, so a regular die. The number cube is fair, so a side is rolled at random. This game is, I copied and pasted that, but I don't know how I got all this stuff. Felipe rolls the number of cube once. He wins $1 if it's a 1, $2 for a 2. I copied and pasted this from Alice, but it didn't copy very nice. $2 if he rolls a 2, $3 for a 3, $4 for a 4, and he loses $4.25 if it's a 5 or a 6. So when you're finding an expected value on a game, as long as it's a game by chance, you put your outcomes. What are our outcomes on if we're rolling a die and looking at the face-up value? 1 through 6. So these would be 1 through 6. Now, most of the problems I found on Alex, they already subtracted what it costed to play. So it probably cost, let's see, what did they have? You lose $4.25. So that's probably what it costs to play. So if you're winning $1, you're actually losing, or you won, what, $5.25? So then this was what you paid. They subtracted it out already. We'll do one where you have to subtract it, but here, so you just put your winnings. A 1 gets you $1. A 2 gets you $2. The 3 got us $3. And a 4 was $4. Yeah. And then a 5 and a 6, we lose 4 and a 4. So they're negative. A negative means you lost. What's the probability of rolling a 1? 1/6. What's the probability of rolling a 2? 1/6. As long as it's equally likely, and it said it was a fair die, so they're all 1/6. To find your expected winnings, you take your winning times its probability. So 1 times its probability plus 2 times its probability. And then the 2 negatives, so minus 4 1/4 times its probability. So you're just taking your winning, you're not using the outcome part. You take your winning times its probability. Are you getting 0.25? So if you play this several times, you will average a winnings, because it's positive, of 25 cents per game. So if everyone in here played at one time, we would probably average 25 cents a game for winnings. Which is a good thing. It's, at least it's winning. But if you only play it once or twice and lose both times, 850, it's a lot. But it does have a winning, after you play several times, it's winning. If it were negative, then if you played it tons of times, you're gonna be losing. Any questions on that one? Let's try this.
I think I can fit.
Raina has a deck of 10 cards numbered 1 through 10. She is playing a game of chance. This game is Raina chooses one card from the deck at random. She wins an amount of money equal to the value on the card if an odd number card is drawn. She loses if an even number card is drawn. Now, we don't want to go even and odd simply because she wins the face value of the card on the odd, so it's not the same amount each time that you're winning. So if it's a 1, she wins $1. If it's a 3, she wins $3. So you do need to put them separately. So write your outcomes, your winnings, your probabilities, and find the expected value. Okay. So there's two ways you could do it. You could list every single one and find the winnings and losings. Or since you lose the same amount every time, she loses $5 if it's an even number. You can look at the odds because they're different, and then you can put even together. You just got to be careful of your probability. Because remember, your bottom row, the probability has to add to what value? 1. Probabilities have to add to 1. Are you getting 0 for your expected winnings? So if you play this in the long run, you're gonna break even. So if it's fun to play, and on average, if you play it several times, unless you're very unlucky, you should break even. My husband will lose every time. So for the probabilities on this one, because we put every single one and we assumed every card was equally likely, what was the probability here? On these, they were all 1/10. So if we add all those probabilities, we get 10/10 or 1. You can always double check that way. Out of 10 cards, to get a 1, this is 1/10. To get a 3 is 1. There's only 1 3. There's only 1 5, 1 7, and 1 9. But how many even are there? 2, 4, 6, 8, 10. So doing it this way, this is not 1/10 because then it wouldn't add up to 1. This is 5/10 because it's the evens. This one, this one, this one, this one. So you do have to be careful of that, but it's a lot less to multiply. If you have it this way, because you're multiplying all of them by 1/10, you could add this row together and multiply by 1/10 one time. You're just factoring that 1/10 out. But when you do that, you should get 0. So on average, you will break even in this game. In the long run. Any questions on that? Using this will find the expected value. If it, that should be an F. If it costs $50 for one spin. Hence, the value of the wheel is what you will get, but you spent $50 to play the game, so it's not your winnings. So this one's not including, like subtracting what it costs to play. So it costs $50 to play. If I land on 500, how much am I actually winning? $450. Yeah. So you gotta subtract what you played out of it. Go ahead and list your winnings. Now, if you wanted, you could, like, I said the 500. If it lands on 500, I win 450. So you can think of it that way. Looks like they're all the same. I just grabbed this off the internet. Looks like they're all the same. Yeah, none of them are P. I was looking for one that did, but I couldn't find one that was legible. This yellow one on the left, this is 250 if you can't see it. getting 76.25 for expected. I don't know, I did it real fast in my head. For your winnings, yeah, 415, -40, -30, 80 minus 50, 30, -50, 50, 200, and 0. What did you have for the probabilities? They were all equally likely, so they were all 180. Then you take each of these and multiply them times their probability. And I got 76.25. So if everyone here played it, we would average winnings of $76.25 each. Or if you play it several times, you'll average $76 per game. If you play it several times, then you can come up winning. But if you lose 2 or 3 times in a row, $50, maybe you shouldn't play. Any questions on that? When you go to casinos, wheels have a better odd of winning than other things. We're going to New York this weekend and they have casinos. I can't. Doing these games, it was like, oh my gosh, I want to leave now. But any questions on that? Okay, oops. Oh, we're still doing more. Oh, I told you guys could work on my math. Is there questions on?
I have a question on projects.
Okay. Or let me shut up the video first.